Welcome to AIM 17. In this AIM, we are going to discuss about point of concurrence. Concurrent points. We know about concurrent lines, means three or more lines meeting at a common point, then we can say those lines are concurrent lines. We saw diagrammatically also, here is a line L and here is a line M and here is a line N. Here L, M, N are passing through the point O. So, three or more lines passing through the common point, then we can say those three lines are concurrent lines, and that point is called point of concurrence. L, M, N are concurrent lines, whereas this O is called as concurrent point or point of concurrence. Let us see the concurrent points in a triangle. Among them, first one is centroid. First one is centroid. What is meant by centroid? Centroid means, already in previous year we discussed about the median. Simply we can say the point of concurrence of medians is called centroid. Point of concurrence of medians. Point of concurrence of medians is called centroid. It is denoted by the letter Z. Point of concurrence of medians is denoted by the letter Z. Let us see the diagrammatically. Now, here it is a triangle and let it be ABC. Now, what is a median? A median is a line segment which joins vertex and midpoint of its opposite side. So, here I am going to take the midpoint of this side and I am joining this vertex and this midpoint. And here this is also one more median and this is also third median. These three are meeting at the same point. So, this point is called as centroid, which is denoted by G. Here, point of concurrence of these medians are telling as centroid, which is G. Here, the sides will be divided into two equal parts. Why? Because this is the midpoint, no? That's why. And here also, sides will be divided into equal parts. And the line segment which join vertex and midpoint to its opposite side is called medians. We can draw three medians in this triangle. The point of concurrence of those three medians is called as centroid. And let us see the next one, which is orthocenter. Second one is orthocenter. What is meant by orthocenter? Simply we can say the point of concurrence of altitudes is called orthocenter. Point of concurrence of altitudes. Point of concurrence of altitudes is called orthocenter. Orthocenter was denoted by the letter O or H. Any one of the letter we can mention. Let me see diagrammatically. Now here I am going to take one triangle which is ABC, and now here I am going to draw the altitudes. Altitude means the line segment which came from the vertex and it makes 90 degrees to its opposite side. Here the line segment and this one making 90 degrees with its opposite side, and I can draw here also, and this is the one more line segment which is making 90 degrees to its opposite vertex, and here it is also a altitude, and the point of concurrence of these three lines are said to be orthocenter. It is denoted by the letter H or O. So how many altitudes we can draw in a triangle? We can draw 3 altitudes. And next thing, third one is circumcenter. What is that? Circumcenter. What is meant by circumcenter? Simply we can say the point of concurrence of perpendicular bisectors gives us circumcenter. The point of concurrence of perpendicular bisectors is called circumcenter. Circumcenter was denoted by the letter S. Circumcenter is denoted by the letter S. Let us see diagrammatically now. Now here also I am going to take one triangle which is PQR. Here I am going to draw perpendicular bisector, and you know what are those. And here perpendicular bisector must be passing through the midpoint of the side and making 90 degrees with it. So here it is a line which is passing through the midpoint of this side and making angle 90 degrees. How many perpendicular bisectors we can draw? Same. Here we can draw 3, and this is the midpoint, and here we have to draw like this, and here it is also making angle 90 degrees. And now one more I am going to draw. Suppose this is the midpoint of this side, and now I am going to draw like this, and this one also making angle here 90 degrees. Now the point of concurrence of these 3 line segments are called as circumcenter. Circumcenter was denoted by the letter S. So here I will denote this by with S. In this way we can represent the circumcenter also. And circumcenter, let us say this is acute angle triangle. How can it be in the right angle triangle? Let me draw. In right angle triangle, let me show you practically afterwards. Afterwards I will show that, and now let me draw here on board, and this is the right angle triangle, and now I am going to draw perpendicular bisectors. And now let me select this one, and this is the midpoint of this side, and now I am going to draw like this, and it is making angle 90 degrees. Now let me say this is the midpoint, and let me draw, and here it is also making angle 90 degrees. And now this is the midpoint of this side, and let me draw and here it is making angle. The meeting position of three perpendicular bisectors are called as circumcenter. It is denoted by S. If you observe in right angle triangle, and we know that it is a right angle triangle, in right angle triangle circumcenter will be lie midpoint of the hypotenuse. Midpoint of the hypotenuse, we can treat it as circumcenter of that triangle. How it will be in the obtuse angle triangle? Let me draw one more figure. Here I am going to draw obtuse angle triangle. Now let me draw perpendicular bisectors. Now this is midpoint, and from this I am going to draw the perpendicular bisector like this, and which making angle 90 degrees with its base. Now this is the midpoint, and now let me draw the perpendicular bisector. It will goes like that. And now let me take the midpoint of this one, and like this it will be go. Sometime like this. I did not drawn in a proper way, so you can maybe. So my intention is to tell that circumcenter will be fall in obtuse angle triangle outside, that too the opposite side of the obtuse angle triangle, obtuse angle. Here it is obtuse angle na. See, opposite side this one na, that outside will be fall. And whereas in acute angle triangle, circumcenter will be inside, whereas in right angle triangle, circumcenter will be midpoint of the hypotenuse, which means on the side that is the hypotenuse, and whereas in obtuse angle triangle, it will be outside of the triangle. So here these are the circumcenters in different triangles. Now let me explain about incenter. Next one is incenter. What is meant by incenter? Simply point of concurrence of angular bisectors gives us incenter. Point of concurrence of angular bisectors. And it was denoted by the letter I. Incenter was denoted by the letter I. And how many angular bisectors we can draw in a triangle? We know that there are also 3. Let me show you in figure. And here is a triangle X, Y, Z. And now let me draw the angular bisectors to this triangle. And now I'm going to draw. Here see, this one, divide this angle into 2 halves, and let me draw one more angular bisector, and this one divide this angle into 2 halves, and here this is the, and here this angle, this line divide this angle into 2 halves, and the meeting point is called as incenter, which was denoted by I. Incenter always lie inside of the triangle. How can we get the incenter? Yes, point of concurrence of its angular bisectors. So in this way we can get the incenter. What about excenter? Let me explain. The last one is excenter. Excenter means, now first of all let me draw the figure, and here it is a triangle, and here I am going to take, two angular bisectors which are from outside, that means external bisectors, and one internal bisector. The excenter will be formed by joining two external bisectors and one internal bisector. Then how can I draw the internal bisector? Internal bisector is nothing but angular bisector only. Now here I am taking triangle ABC, and this is the angle which is inside. No, that's why I will call internal angle. Now I am extending this one like this. So let me write this letters outside, and this is C and this is B, and here are the angles, and this, if I draw here, these are the internal angles. Why? Because the angles are inside of the triangle. The angles which are inside of the triangle called as internal angles. The angles which are outside of the triangle are called as external angles. Now I am going to take one internal bisector, means like this, and which divides the angle into two halves, and I am going to take the two external bisectors, and I am selecting this one, and now I am drawing this one, and here this one divided into two halves, and now I am going to take this one also. Like this will go, and here this one make, and this point is called as excenter, and this is called as I1. How many excenters we can form for any triangle? There are three excenters. One is opposite to A, another one is opposite to B, and another one is opposite to C. So we can draw three excenters for any triangle. Excenter means the point of concurrence of one internal bisector and two external bisectors, and it is denoted by I dash or I1. We can draw three external points for any triangle. So now I think you can understand about this. Let me show you how to draw circumcenter for any triangle by paper folding method. See, this is a small triangle which is acute. Why? Because all angles are less than 90 degrees. Now let me fold, and we know that, what is that? How can we get the circumcenter? How can we get the circumcenter? The point of concurrence of perpendicular bisector. What is meant by perpendicular bisector? Perpendicular bisector should go with the midpoint of the sides and making 90 degrees. See, I am folding like this. If I fold like this, see, means at midpoint, and this is the side, this is the midpoint, and making angle here 90 degrees, and here they making angle 90, and I am selecting this side, I am folding like this, and these two vertices are coincide with each other, means I will get the midpoint, and here the line making 90 degrees, and I am selecting third side also I am folding, and here two vertices are coincide to each other like this. So here, see here, These are the crease marks. See? And see, every line making angle with its base 90 degrees only, here and here. And the point of concurrence of these three perpendicular bisectors is called circumcenter. By paper folding method, we can make the circumcenter like this. This is acute angle triangle. Now let me take right angle triangle. See, this is the right angle triangle. Why? Because here angle is 90 degrees. In the same way I am folding. First I am selecting this side and I am coincide this side with this vertex with this vertex. And see, I folded here. If I fold any paper, definitely it makes 90 degrees with its base. And here it is making 90 degrees, and it is also a midpoint. And now this side over. Now let me fold this side, and this vertex should be coincide with this vertex. And now I am folding like this. See here, and here it is making 90 degrees, and this is the midpoint. Now I am folding this hypotenuse, and this vertex is coincide with this vertex. Like this I got 3 foldings. I am turning this one. See, you can see here this line and this line and this line. They are meeting. See, this is the right angle triangle. First of all, this is the midpoint of the hypotenuse. See, if you observe, all these lines are meeting at the midpoint of the hypotenuse. So, in right angle triangle, circumcenter will be on the midpoint of the hypotenuse. And what is this? Which type of triangle is this? Yes, it is obtuse angle triangle. Why? Because here it is the obtuse angle. Same thing, if I fold this one, see, I drawn back side. If I keep here obtuse angle triangle, means here it is a right angle triangle. If I like this will go, and this like this will go, and like this it will go. Let me draw again, and if I join this one, and it is go, and here it will be fall for obtuse angle triangle, and here is a obtuse angle, and this side will be fall. We should extend the lines. Why? Because this is obtuse angle triangle na, in that way. And here the most important thing you have to remember is that in equilateral triangle, circumcenter, incenter, orthocenter and centroid coincide with each other. In equilateral triangle, circumcenter, orthocenter, incenter and centroid coincide each other. In any other triangle, the circumcenter, here I am writing orthocenter, which is denoted by O, centroid is G, circumcenter is S, or lie on a same line. That line is called as Euler line. In coming classes, you can learn about this very well. Thank you.